How's it going, everyone? Welcome. Eulier Gonzalez. Let's take a look now at this particular chapter when we're describing, or where now Kyle Simpson is describing about the global scope. Particularly, this book, which is about scope and closure, is a dive into the understanding what a scope is, what a closure is, and what it enables us. So, what is the practical sense of knowing this in our code base? So, all of this is just to now, once we understand this scope, is to look at patterns that allow us to organize our code. That's the whole point of scope and closure, or at least that is the main selling point, right? So, to get that, all right, we went through this series of books. Specifically, first is the Get Started, like this. So, with the Get Started, we make a quick overview, or I went through this quick overview in 3 chapters where Kyle Simpson eloquently describes not only the inner low-level feature of the language, but also what is around it. All right. So by going into the macro, sort of speaking, to understand is what the name of the language, so where the name of the language came from, who made that, and now who owns the legal trademark, who oversees the spec, which is this TC39 commit, what is the role of this commit, what is the motto, and how now they guarantee that specific features are implemented according to certain quality standards, right? Or these 4 stages that it 5 stages that it has. So from stage 0, because we as programmers started to count from 0 to 4, and how now particularly champion or proposal have to wait all the way up to the top until it is being uh, until it is part of the spec. So this doesn't guarantee that JavaScript implementations, aka JavaScript engines, now stick to the law, because due to legacy reasons that go beyond the scope of today's video, they need to provide to support certain legacy features. All right. So, for example, without the using of a strict mode, again, something that we're gonna see that later. But this supporting these legacy features is something that has some drawbacks, and one of them is that they need to guarantee that the web doesn't break, and in order to do that, they provide now polyfills, which are now implementation of these new features to older browsers. So this is code for this is browser safe code, right? Which is a fancy way to say, hey, this will work across any browsers. So also, the difference between these JavaScript implementations, and especially on the dev console, that despite that the intent is was for the developers who made this dev tool, is to provide a JavaScript friendly environment, or a strict compliant. And don't take my word for granted, you can take a look at how these environments behave, and they don't behave the same as the spec described. But in any case, this environment was not designed to be a fully compliant JavaScript spec. It's just to test a small snippet of code. And that's when, for example, things like street mode doesn't work the way that it works like a normal file, right? And how now in what is this strict mode? Because in order to guarantee that JavaScript give us the best performance, the JavaScript engine give us the best performance, or have a good chance for optimizing or running our code, well, we have this set of rules of how we need to write our code. So this concern about if JavaScript is a language, is a fast enough language, is mainly due the tag that language has. For example, compile versus interpreter. In any scripted language, aka a interpreted language, uh, historically has been like a with disdain, or in any case, is not that performant as compile language. And the reason is something that I'm gonna briefly explain is how now it process that particularly uh, source of text, that program that you write as a programmer. So the way how it process that, because it's different in the way how JavaScript process these files, particularly the way how it analyzes these files, it looks like a compile language. That's what is in essence, if not in practice, JavaScript is a compile language. Why is this? Well, because the observable behavior that we can appreciate when JavaScript now evaluate, for example, syntax errors or early errors, some specific errors that is describing on the spec, and also is hoisting, right? So these behaviors that you can actually see what's going on. I don't break that up. Is, for example, a good syntax error here is to say, hey, guns salute, all right, and here you say, hey, this is now hello, for example, right? Come on. And then you want to say, hey, console log of salute, right, to see what salute has. And diggy. All right, and then I'm gonna say, hey, whoop. Let me put it this way. Yeah, let me put it this way. Let me say, hey, you say it's a function. Function say something. Okay, function say something. You say function say something. In this function, you say, hey, I'm going to say, hey, console log is salute, right? So console log is salute. So let me put it this here, right? Let me put it this thing here. Diggy diggy. Yes. Okay, this is the example. This is the example. Let me define here, and also define here as this. So console log here of salute, right? And if we say something like this, the thing is, you say, hey, well, if I do this and then I do that, well, how now JavaScript gonna know that this variable is already defined? Shouldn't throw any error here, and you are right. But the thing here that it throw now not only a reference error, it throw now a syntax error. This is part of this early error or errors that evaluate first before our code is even executed. Okay, there is another examples here. So for example, if you say var salute, so hello, and the syntax error is something like this, and the other is a var salute, and then you say diggy diggy, var hello, say var another salute, right? And then you say salute like this, and then you say something like this. And I know that this might sound quite silly, all right? It's like, hey, you can't do that. I know that you can, but let's see how this intuition should works. If this is an interpreted language, it's supposed to evaluate this one of line, and then now throw the error. In any case, show you the salute here. But it turns out that this actually throw you is this, the syntax errors. So the idea here is that, in essence, if not in practice, JavaScript behave like a compiled language when it comes to analyze the code rather than a distribution role. So, because this concern if JavaScript is fast enough, back in 2013 there was a group of engineering in Mozilla that say back in 2013, so a bunch of software engineering at Mozilla, they now present this and set a precedent that JavaScript is fast enough because they pour now an Unreal game engine into the browser at full 60 FPS, right? By creating a subset of the language that target is the engines and provide hints to optimize the execution of the code as well as the parsing. This was now, as I mentioned before, a precedent that JavaScript is fast enough. And then years later, the spiritual successor, which is the WebAssembly, say, hey, good, but let's take now things a little bit further by eliminate is now the parsing phase, and now have this interpret this representation of the language that looks like as an assembly, all right, that we can now run in any WASP environment, in any environment that can run this WebAssembly code. So by WebAssembly becomes this universal portable, this universal compiler target. Now, well, you can now pour is application from Rust, Ruby, Python, you name it, into this into this WebAssembly code that can be run in any of these in any of these environments. So I do think that this particular overview of around the JavaScript, and then look at now a little bit further of the JavaScript, at least you know is the basics, okay, which is what a value is the most important. First, how a program is analyzed by JavaScript engines, how different individual files are processed, how they can now is act as a single one at runtime, okay, when they share their state, or if they are now importing elements, or if they are importing is different ESX models, what is the value, which can be silly, but it's important to understand from there, okay, what is the representation of a value, what is so important to have value in our programs that allow us to describe is the state and manage the state of the programs, and the different representation of value that we can have, string and numbers, each one of them follow a specific format or spec, right? Whether it's Unicode or IEEE 7054, and also we have is Boolean values, big int, symbols, and kind of emptiness, like undefined and null, as well as objects. And how in objects, because objects behave like a record and a dictionary, it can be now is a collections of values as well as functions. And because functions now are values here, uh, well, we look at how can we define those values. What is the role of function in JavaScript, that it can be as a procedure or a pure functions, and also to understand that the language, the function in itself, that you can held that inside of a container, which is a variables. We have two ways to represent values in our programs, whether it's literal or a variable as a container, the different syntax form, as well as it is inner behaviors, var, let, cons, as well as the other places where we can define functions, where we can define variables. So for example, like functions definition and function expressions, as well as in for as well. So this is a huge overview of the values, and also what we can do with values, whether it's compare them and to convert that to one to another. What does it mean comparing values, which is a fancy way to say, hey, this is a referential identity, or I'm comparing it by its identity. Again, this go beyond of today's video, but I just want to make a quick recap of how do we get here. In this values, this this operation that we can do in our values, whether it is comparing values or converting that, okay, each one of them follow a specific algorithm that we must know in order to understand how to work with them. All right. And another important thing is that how we are going to organize our programs, whether it's as a class or a function or as an EX6 models. And understand this, that JavaScript support different programming approach to solve problems. So for example, when computation is the problem, when you need to compute or to calculate or to derive data, now functional programming makes a lot of sense to go with. But if your applications now require collaboration or cooperation, object-oriented programming makes a lot of sense. So this is just to describe this huge overview, all right, of JavaScript, and then look at the root, or at least up to 2019, the digging into the low level feature, into the root of JavaScript, which is iterations, and how now JavaScript provide is this convenient way to iterate through a collection of values, which is something that comes from other programming language like Python, for example, when they have, and this is a pattern from design patterns, all right. And this design pattern is that, hey, we as programmer, we are facing these recurring problems. Anytime we, for example, create an object or we define it as a structure to enhance that, to make it flexible to work with, or when it comes to describe how it's going to behave. So for example, hey, how it's going to behave when I iterate through these collections, how are you going to iterate, how are you going to behave, or what will be the responsibility of this of this program, right? So this is why we look at the iterator approach, and also there is another common design pattern, which is the, hey, how we going to make now is the how do you put it? How we gonna make now? How can we in our programs solve when series of eventual value comes here, or how can we look with some sort of data is emitting values of data, right? with uh, the the event emitter approach, or the observer patterns. So, but the idea here is that you don't need to memorize each one of them. There is no point in memorizing it. What is value is that to understand what you need to do anytime that you see yourself in that particular problem. All right. So, for example, because a recurring theme in JavaScript application is that we need to iterate through series of collection of values. Well, now some champions or some TC39 members, they actually promote and propose, is now officially available since 2000, since EX6, all right, 2015, uh, that hey, this is the way of how we're going to now iterate through a collection of values. This is the conventions to do that. So these conventions now follow is the iterator protocol, where it say, hey, this iterator protocol that points to that data source, it exposes a function called next method, all right, that anytime that you call, it will give you the next value and the next value and the next value and so on and so forth, right? So you can think of this like when in your cell phone, all right, that anytime that you write a message and you send that, this is how this is going to behave. But in this case, instead of sending message, we're gonna get this new value here. Another good example is like when anytime you want to refresh in your application, well, you scroll down, right? You tap and hold down, you tap, hold, and scroll down, and you see now fetching that data, right? Fetching that data, which is pretty much a very convenient way of how we can look at this real life example. So in any case, as I look at now that this iterator, which is the protocol, is going to be is going to point to that data source, and that data source must be an iterable. This is a fancy word to say, hey, if this value, can we iterate through these values? And in order to indicate that is by describing the particular object with the symbol dot iterator, which is a badge that say, hey, this iteration we can iterate over, and this is its behaviors. So for example, if you define, so here, let's say an object here, right? And inside of these objects, you do want to define is a iterate. You do want to define is an iterator behavior here, okay? Because unfortunately, by default, let's say you have now name and you have now just a layer. So you want is to now iterate through is last name and the age. I know there is no need to put it here, but it's just an old habit. This A35, right? So the point here is that normally you can iterate these values as it is. You can say of object, all right? This particular syntax which is implementing is that normally you can iterate this because it tells you that, hey, this is not an iterable. But what you can do is to say, hey, you know what? I want to make this object iterable. I want to put not only I want to make this object iterable, I want to now is describe how we're going to iterate through this object here. So you can say, hey, symbol dot iterator here, Okay. I do think it is. Yep. We can define it as this, or under the prototype, prototype as well, where you can describe is the behavior, and this behavior must match is the iterator protocol, which means is that at the time that I'm receiving is this value, where I going to have access to this keyword. All right. Let me put it here and say, hey, this will be the object. Okay. And then, because I want to iterate through each one of them, I can do some good old style here and say, hey, how many objects do we have? So how many properties do we have here? This is the length properties. Okay. And I can say is, hey, object, hey, I want you to give me is now uh, the descriptors that which is get on property names. Exactly. So get on property names of these objects, and give me is the length of this, right? So then I can manually create this or imperative create this and say, hey, let me write this code here for you. Let me indicate you JavaScript engines how to do these things. All right. Okay. So here we can say is let index that start from 0. Okay. This is the initializator. This is the stop condition until it is less than the length properties. Okay. Hey, is I less than length property? When it reached to that level, it's gonna count that. So it'll start with 0 and then out to the length. Yeah. So what it's doing here is to say, hey, I'm gonna start from 0 until one value less, and because now length property give you is this fully, all right, it doesn't count from 0, it starts from 1. So that's why we are now getting into this is the condition here. So next is the after through, which is, hey, what you want to do after we evaluate this block of code. Well, increment the, and here you can define is functions as well. You know, you can define its function, you can define its also even closure. But in any case, let's going to stick with this. All right, so so what I want to do, okay, what I want to do is to is return. Okay, so what I want to do is to return now a function, or in this case an object that contains the done, which is part of the protocol that needs to be done, that say, hey, if this is exactly, this is part of, now we need to implement is the iterator protocol, where it say, hey, this needs is 2 properties, the current value and it is done, to indicate that whoever is consuming me, hey, you reach to the end. Okay, so done is going to, we can say this is done and say, hey, initially is false. Oh my god, no, initially is false. All right, so I want to return this and say return done is done, or to make it much, or to make our life much more simple, we can say done exactly. I think it's done, and the other is the value, which is, hey, uh, uh, on the object, okay, I do want is to now uh, have access to the value at that moment. All right. So because we want is to have access to that value of that moment, another thing what we can do is to say, hey, uh, hold me this, not only the length, but also is the property names, okay, so I can now have access to that data quickly, right? So I can say, hey, this will be is the property names, which is now the collections of all of these names, and since I want to have access to that elements at that position, that it's gonna give me is the current value at that, then uh, I do want is to now with this name value, please give it to me is the value of this object. All right, and once this is done, all right, I do want is to now return is this. So you might wonder, hey, is this gonna work? This will be true. You might wonder, hey, if this is gonna work? Well, it turns out that anytime that it runs this function, what happened here is that it's going to recreate all of this every time. And because we want to somehow now to store these values in order to make it so anytime that we call that later on, we hold a reference of these values. We need to is return is a function that allows us to do this, right? So in other words, here what we can do is, hey, while done is false, so while this is false, all right, I want you to now evaluate this. I want you to return this. Dig it. All we can do is this. So anytime that you call this function like this, I can do that in an iterative approach like this. All right. Exactly, and then define this. So hey, if done does not exist, if done is false, well, this is what I want you to do. So if we are not done, hey, this is what I want to do. Okay. However, if this is done, so return always true as it is. So by doing this, an invalid shorthand property initializer, which line? 21. Is this exactly? And return done is equal true. Oh, it's because it's this one. That's right. So now it say, hey, cannot set property of undefined setting symbol dot iterator. It's actually telling you that this is a type error, and it say that I do think that is under here. Undefined is not a function. Mm-hmm. Yeah, let me actually see. Let me actually check my understanding here. Because my flaw is that how can I now access to the symbol.iterator here? Object don't have prototype property. Oh, exactly. So object don't have prototype objects. Prototype. So I do want is to access to this. But it say that undefined is not a function. In line 28, undefined is not an option. No, it's okay. It's good because what I'm doing is just to look at my flaw in my understanding. That's all. Missing next method. Oh my god, yes it is. Oh my god, it is. Exactly. It is. It is the next method, exactly. So on the symbol.iterator, exactly. On the symbol.iterator, I need to return is that. Okay. Yep. So on the symbol.iterator, I need to return is the next function. So I need to do is this. On the next here, I need to do is this. I need to return is next as a function here. Okay. I need to return next as a function here. Where here is when I'm gonna check that. Which is, hey, is this done? Diggy. Alright. Hey, is this object that you're returning contains now the next function? And any time that now the symbol iterator is being called, is say, hey, this next function is going to now is, well, check for is done. If done is true, hey, we're not done, so let's go to iterate through all of these elements, right? However, if it is, well, do this. Return now is this one, right? And now, ooh, no. Close it. No, it's okay. So the question was like this. It's now casting is this, so it's calling this. So we are not updating is the done value here. Exactly. So hey, if this done, no, let me now iterate through this and return you that. And this will never stop, alright? And then we can say is, hey, let's gonna set done to true. Alright? So after you evaluate that particular code, now done is true. And therefore now this might work. No, the patient side. Kill it. Shit. So what happened here is that, but again, it is working because it's continuously to call that. Well, yes. But it's now, okay, but it's now it's calling my only one. Oh, I get it. It's because it's starting from the, okay, it's because, okay. So we can simplify this a little bit by saying is this. Let me define this as 0, all right? And then I want to, on each iteration, go through that. So in other words, is do something like this. So to have now manual control over this stuff here. So in other words, we say, hey, if we're not done, okay, so we can say, hey, if I is less than the property name, or in other words, the length property, okay. If I is less than property that length properties, if this is true, well, let me now return that object as that moment. Another thing that we can do is to well, let me is increment but not return it its value. Okay, increment but not return it its value. That's what it is. And now access to that. And you're gonna do this until the length property is exhausted. All right. Which meaning is exactly. Which meaning is that we can say done is false and then done is true. There is no need to check this, only this. It will be our counter, and it say unexpected token return. Oh, because I haven't put this way. And now you get it. But it start to count now. We can start it by -1 in order to fix this, right? Euler, Gonzalez, and so on and so forth. But again, this is how you can now is manually control is the execution of this function as it is. So in any case, what we did here is just to implement now a logic of how can we implement our own iterator, okay, for values that doesn't have that. So because we don't need to implement this particular logic for certain values that can be quite annoying, such as well, iterating through streams or map or set or arrays. Now we can have access to this. We can iterate through these collections by using this particular syntax. And that's what is the mind-bending stuff of all of this. exactly, because it is calling like once again. Exactly. But again, this is exactly what we did here as it is. Another thing that we can do is to say, hey, instead of doing this, all right, instead of doing is this increment, we can say, hey, increment this value, but don't return this value yet. Hold it as reference, and therefore, now we do this. In other words, we can say something like this, and this will work. This is why this plus and minus actually makes sense, but it's all about when this function is being called. All right, and if you want to hold a reference to the new value in the next iteration. So this is just to implement this. All right, and I know this video was not about this, but I do find that this is important in order to understand this particularly low-level feature and also fill my gap, fill the knowledge in my, fill the gap in my knowledge on the symbol.iterator. I do find this is quite interesting, very important also to understand now how you can even implement your own iterators. All right, and there is a lot of things going on that we talking about that much. All right, we haven't talked about that much, but it involves inserting other low-level features. One of them is function expressions. The other is the how now these variables can have access to this and somehow record this, which is closures. And also is that how is that we have access to this value when we call this function, and this is also the object in it itself. Well, because this is how now this is a property of the functions that allows to access to the execution context via the this keyword. So and also is that the something called as the object of property is like how this actually work. What is the object here, and the property and the prototype as well. So this concept of iteration, and this actually illustrates very powerful if you truly understand now the low-level feature of the language. So for example, the iterator. Exactly. So for example, the iterator. Oh, okay. Holy moly. Okay. So for example, the iterator. Another is the scope here, because we are creating is now a scope per functions, and a scope when we are returning is this as an object, and it also is creating now a new scope here as a function by returning is this next function here. And another thing is that the again this low level feature again from this book, which is also there is another thing like the proxy and metadata, something like that this book hasn't discussed about it, and I'm going to look at that. What is the main use case for doing so? Is that hey, we have is scope, which determine is how now a variable identifier is resolved. Happens before the code is executed, and also is the this keyword. What is the this keyword at the end of the day, and how you can. This is not whatever is on the left side, as a lot of people actually argue here. It is that you can now have access to this data at runtime, and even you can modify the data at runtime. via the bind and call and apply. And then the the closure, all right, and also the object of prototype, which is a way of how now property names are resolved. It's a way to delegate is the property access from one object to another object through the prototype link. And I do find that this is very, very revealing here. So, because of this, right? Uh, the book scope now weighing through this, especially to understand one of the most important topic across any programming language, and that is scope, and the other is the closure as well, and how particularly in JavaScript how that things work. Another important thing in JavaScript is to understand now how to work with objects in classes and the type system. So in any case, let's get into this. Let's get into this. I'll be right back. Give me a second. All right, and we're back. Good, good. Now, the three things here that are important to understand in JavaScript, and I do argue, not argue, and this is also important to understand in other programming languages, because when you understand these fundamentals, and to me it was quite hard. It passed through a lot. Humans spend too much time in doing things that are not effective, and I was one of them. And now this is why I'm actually recording this series of videos in order to understand this. So yeah. Well, so here in the scope and closures, we first look at the to answer two questions here. So first is that how does JavaScript knows which variables can have access at that particular statement, and the other is that how it does to resolve variables with the same name. Okay, so it all boils down to scope. And scope is the way now how different scopes, for example, it is syntax forms like functions, block, and also catch. But for the sake of the example, is the functions and the block, how they relate each other in order to resolve which variables, identifiables they belong. So, because the way how now this scope is determined is in compiled language is before the code is executed. And since JavaScript is a scripted language, so in classic computer in classic compiler theory, this scope is determined is before the code is executed, all right? And this scope structure, which is this, you can think of this like a record, like a series of records, right? Like spreadsheets that indicate is that which variables belongs to which scope. So now this record here, this scope structure that is defined before the code is executed and is not modified by runtime conditions, and because now functions allows to define is this is also interesting. This is getting to the philosophical aspect of this, and not that philosophical because it is the truth of this. So because you can do things like this, say, hey, this is a block, right? Because you can enclosing blocks here. This is just to how to create an object, right? Not a block, all right? Not a block, all right? When you say, hey, let salute, right? And then you say, salute is hello, or say hola, right? And then you want to console.log that to say, hey, console.log that. What do you think will happen? In my case, it will now, it will throw an error. Oh no, it's actually evaluating the code. That's good. That's good. That's interesting. That's interesting. So it actually indeed evaluate the code. So it doesn't need to do this. It say, hey, this is a curly bracket. This silly syntax. This silly syntax is indicating that, hey, no, this is not an object because the next word, the next token was a let, and then the identifier and so on and so forth, right? But if, for example, if I do this as a function here, all right, and then I say, hey, console log of what? you know, it will say, hey, I'm going to evaluate this, but this is now a function. But again, it creates now an object with the name object here. So I just want to illustrate that this block section like this, since there is no way to hold this as a value, okay, you say, hey, let's say this is instructions, set of instructions, because you cannot hold this set of instructions as a block. What you can do is to hold this set of instruction is as a function, okay, and they become now a value here. And since in functions we can now is define is variables, and it is identifiers, this scope structure is, so this scope structure won't be affected by runtime conditions, by when the function is executed later on. So in order to understand that, this is why we went through the classic compiler theory to say, hey, well, this compilers is made of three phases. You have now the tokenizer or lexing, which is the lexing and the tokenizer. This is what it does, is to determine, hey, this is a good example of how now the tokenizer works, right? This is a good example of how the tokenizer actually works. Is this a good example of Is this a good example of how the tokenizer works? The tokenizer works in JavaScript? All right. Function salute. Hello. This is a good example of how the tokenizer works in JavaScript. No, this isn't a good example of how the JavaScript tokenizer works. Let me explain why and show you what tokenization actually involves. What you're showing, your example demonstrates scope and declaration difference, not tokenization. Block scope within with variable, block scope with a function. What tokenizing actually is this. Is that say, hey, this token belongs to a number, this token to a string. This is an identifier, an operator tokenization, and keyword identifier. So while your example isn't about tokenization, your example will produce nearly identical token. The difference is in parsing how tokens are structured in AST and scope resolution and execution. So, okay. This is relevant to scope and declarations. Okay. Yeah, this example is, but again, the examples remains to say because we can only hold values, uh, because we can now hold functions as values, and the functions and the scope, and since we can define its function inside of variables and define inside of those functions variables, identifiers, names. So this is scope structure that is determined before the code is executed. No matter whatever you call this function, it won't be so whatever you call this function is gonna have that scope structure. So this is why we talk about is the compiler in the classical compiler theory, with the parsing and with the lexing and tokenizer and the parsing and the code generation, all right, and how now the observable behavior here in JavaScript is that the way how JavaScript analyzes syntax errors as well as early errors in the hoisting, all right, all of this happening is before the code is executed, and especially with hoisting is when you have is this, you say, hey, function say something, right? No, exactly, okay. So function say something here, hey? But specifically, when you now do something like this, let greeting of howdy, you know, let greeting of howdy, okay? So the scope structure or the closure, this is also determined is at before the code is executed, because what you might expect that this is it. Well, because now this is our different scope block and functions is going to say, hey, this is an error because despite that despite that let and counts are hoisted, they don't have their initial values are not undefined, so they don't have any reference. This is the temporal dead sum. So it's going to throw you a reference error here. Holy moly, bro. So this example here of say something like this, and then you define here your var that will be widely available through the function. You say greeting, okay, and then you say now the hello. And I know I'm repeating myself a little bit, but it's just to, and then it's just to describe is this process, and then you define now a new scope, which is a block, and here you say, hey, I do want to have access to the greetings, all right? So this, when you call this function like this, it won't cause any errors. But if you, for example, define now is a variables, the same variables here, the same name variables here, and then you're trying to have access to this before, because this belongs to a different scope, and this is something that is now, it throw you now an error before the code is executed, all right? So in other words, this scope is computed is before the code is executed. This is when you get this particular errors. So again, I'm doing this is just to clearly now understand is that is the scope in itself this is determined before the code is executed at this. Okay, so and then well, now how the association of these values to an identifier happens if this is a target and then the source, and this just now points out the lexical scope, the lexical structure here, which is, in order to illustrate this lexical scope, Kyle seems to make some several examples here. So for example is the marbles are variables and buckets are scope and bubbles are how wide this, for example here, like bubbles here, how now widespread this marble can have access to. And all of this is just to have at least a visual representation of what it is. But it also is that what is going on, at least to develop this mental model, which is this understanding of what the scope manager is doing before the code is executed and when the code is executed. So before the code is executed, the scope manager now, or the compiler asks the scope manager to identify it as names, to resolve these names, to resolve these names or these identifiers. And then when the code is executed, the JavaScript engine now asks to the scope manager to say, hey, now I have this particular reference that I need to assign this value. Hey, do you have this reference? If it's not, that's what happened. So this is because it's going to evaluating is this. So if we went through this step by step and we say, hey, if this is JavaScript is an interpreted language, we say, hey, let's going to run this code. All right, it's going to create now a function execution context as well as function environment records. All right, that it say, hey, this, my friend, it say, hey, this is the compiler first. Hey, scope manager, if this is first, this is the assumption if this a JavaScript language is now a interpreted language, right? If this is an interpreted language, you might say that, hey, every line of code now will be evaluated as your intuition, you know? For example, like this, hey, we are assigning now this value, hello, to the greeting, and then on the second line we should is now read whatever value do we have in greetings. And, well, then reassign somehow that value with howdy. But that's not how this works. It throws you now a reference error. It means that now the JavaScript have two phases. The compilation phase, for example, or the analyzing of the code, and the other is the execution of the code. So in order to now understand this scope structure and what's going on, and especially how it's going to resolve these particular variables here, because functions and blocks create its own scopes, we look at the different places where we can define scope. All right, holy moly. So functions is one of them. This is now what we talk about in chapter 4, chapter 3, sorry. Yep, so chapter 3. So we talk about is now function scope, okay? And when you have now functions or block nested to each other, right? They internally have a reference to the outer scope via the outer.env. So the thing here is that with functions, which was a simple example, right? With functions. So now if we say, hey, this will be is a function, it's a function. It's a function. And if we try to return that function, you say, hey, is this function? Say like this. So say something, we're gonna return that function, but if we call say something twice, okay, it will now say the same error. You might wonder why is this? Again, it's because the way how we're using is this variable syntax form. Is the way how now this way of holding values in our programs behave. So that's very, very interesting, by the way. So in order to now understand the scope, which is something that we described, and now how the scope happens, and also to answer another question, which is you got it. And now to answer is another questions, for example, like how now JavaScript, all right, figure it out is so for example is this, if we say this, what do you expect that this the greeting will be? Well, the greeting, hello, right, which is going to print is hello. So how now JavaScript node is this, and also is that how now JavaScript is solving things like, oh my god, things like this, right? Right? So now how JavaScript here is solving is this names, this nested, this variables name nested with the same name. How does it work? How does it solve this? Well, it solves this through these things now shadowing. So this shadowing is when variables with the same names in different level in different nested scope, that's when shadowing occurs. So again, it is shadowing because now this new definitions cannot have access lexically to that reference. And you might wonder, it's like, hey, yeah, but I can access to this. For example, if I say something like, this, right? It's gonna make a code that is much more intuitive. So for example, like this, right? And then I define is a new function here to return that new function here, right? And then now, for example, like this, and say is hello. Hi, in French, in German, and hi in French, and hi in Portuguese, right? I don't know. How do you say hello? Exactly, it's hello. Hello, my bad. Is hello. All right. Hola. This one. This is another one, right? I prefer to go with the hola here. All right. So here you can say, hey, at this moment, well, I can access to the hola. So if I call this now several times here, right? If I say something 3 times, okay. Well, I'm gonna output that, right? Hola and hola, right? But if I, for example, now do this, of course, that'll be shadowing here. And you might wonder, hey, yeah, but I can create now something like this, you know? I can say, hey, this is greeting, or this is, let's say, is a greeting reference, all right, of this greeting, all right, and then somehow I have access to this. Yes, you can, of course you can, but this is now copying an object. In other words, it's creating is a reference from the object value, not lexically. All right, so there is no way to lexically access to this middle value here, or even this here, right? You can create copy of that, but that's it is. But in any case, this was just to illustrate that shadowing is something that happened when you have now variables with the same name in nested scope, and also another place where we can define is scopes here, right? And these lookups are more conceptual. Yeah, copying is not illegal shadowing as well. So for example, is this, but if you do this kind of stuff, now it's going to quite behave pretty fucked up. Okay, and the other is that exactly the other places, so or the other places where we can define scopes here. So that is not only as function, and because functions definitions we can define as it is reference. Sorry, with functions name scope, we can define. Yeah, with function name scope here, we can is define that's okay. So with function name scope, yes it is. Exactly, with function name scope, okay, it's now looking is at the different places where we can define scope, whether it's function and arrow function, and both of them have it create its own scope. The thing is that the nuance are different, and when you can apply this, and why this is useful to name your functions and be explicit about that, not only because the function names when you define that scope is lexically available, All right, so you can reference that and work to do that. For example, to do some recursion, some stuff like that. Uh, but also is the the other places where a scope can happen, which is parameter scope. That's to me was mind bending stuff, bro. It's like, what the fuck? Implying scope, parameter scope, and function name scope. So in parameters, here we can, anytime that you create now a parameter, indeed is creating now a parameter scope, aka you can define now is closures inside of that, or even shadowing properties. So the TLDR is that never shadowing parameter with local variables. So never shadowing is parameter with local variable. That's a recipe for disaster. In other words, if you don't want to have access to that, never shadow parameters with local variables. Avoid using a default parameter function that close over any other parameter. And the other is a function name scope, and anonymous versus name functions. This is more like opinionated, okay, where you say, hey, yeah, I do want is to um, write this code to be much more readable for myself and future self and other people's. So for example, with the name inference is incomplete, the lexical name and the use names functions, so names are useful descriptors of what these things are doing, and especially when you're defining is all of this how do you put it, when you define is a chains of computations. This is also important because not only for synchronous chains of computation, but also it's for asynchronous nested chains of computations. Holy moly, bro. All right. You can also define as this function as it is. Immediately invoke function expression with a unity. To be and avoid. Okay, to be and avoid is okay. This is now okay. This is now waits to okay. Yep, it is, and and immediately invoke function expression to say, hey, this is to indicate, hey, JavaScript, I don't want you to parse this, I just want us to execute this. So parse and execute this. What? Oh, I need to call this. Exactly. Mm-hmm. Mm-hmm. Yeah, because they say, hey, this is an invalid token. Okay. To say, hey, want to now clearly communicate this. Interesting here. So now this is on chapter 3, and then the other place where we can define our scope are in the global scope. All right. So there is not enough. Okay, this is another place where we can define where scope are. Mm-hmm. So it is good enough to just assert, avoid using the global scope and be done with it. The global scope of JavaScript programming is a rich topic with much more utility and nuance than you will likely assume. This chapter first explores how the global scope is still useful and relevant in writing JavaScript programs today. Then look at differing in where and how to access the global scope in different JavaScript environments. This discussion here was to illustrate is uh, the other scope that is in the language, the global scope, and why most applications that are composed, most applications, all right. So how exactly do all of this, and this is to answer a particular question. How is all of these different standalone files act as a single program uh, at runtime? So in other words, how these different separate files stitched together into one single context by the engine. And they are with respect to browser executed applications, exactly. And with respect to browser executed application, there are three main ways. With respect to that, with what is exactly is this global scope? With respect to browser, with respect to browser executed application, there are the three main ways. And what is exactly is this global scope? Whether it's on the browser window, global shadowing, DOM globals. Okay, where exactly is this global scope? The window, the global shadows, the DOM globals, the what is in window name, and the web workers. Okay, it's describing now where exactly is the global scope. Whether it's on the browser, the window, where you can do the global, okay, whether it's on the browser, on the window, or the web workers. And developer tools to console here. This is another scope here. And the ES6 model. And Node. This is describing is this global scope. Where exactly is this global scope? On the browser window, on the web workers, the developer tools, the ES6 models, and Node, as well as the global this. Reviewing the JavaScript environment we have looked so far, a program may or may not declare a global variable in the top level scope with var or functions declaration. Wait, what? Reviewing the JavaScript environments. We have looked so far, a program may or may not declare a global variable in the top level scope with var or function declarations, or letting constant class also add global variables declaration as property to the global objects if var or function are used for declarations, and refers to the global scope object for adding or retrieving global variables as property with window, self, or global. Where the global scopes are. Where exactly is this global scope? Okay, on the browser, on the web workers, in the console log, Node, and ES6 models. Okay. Holy hell. The global scope is present and relevant in every JavaScript program. Even though modern patterns for organizing code into model, the emphasize much of the relying of storing identifier in that namespace, still, as our code proliferates more and more beyond the confines of the browser, it is especially important we have solid grasp on the difference in how the global scope and global scope objects behave across different JavaScript environments. Across different JavaScript environments, where the global, where is the global exactly? Where is the global scope exactly? And it is specific to this environment. On the window, on the window, on the object, in the window, on the window. on the window, the browser, on the developer tools, on the ESModules, on the WebWorkers, and on Node. With the big picture of global scope now sharper in focus, the next chapter again descend into the deeper level of lexical scope, examining how and when variables can be used. So I do think that that'll be all for this video. Take care. Bye bye.